Hi. In this video I'm going to show you another way to calculate the value of a. So it's just as a reminder, it tells us both whether the parabola opens up or down, and also whether it tells us its vertical stretch factor, so whether it's skinny and tall, so that would be for an a value like maybe 2 or 3 or -4, or if it's short and fat it might be like a half or -1/3. Okay, and this way is an algebraic way. So you don't have to do the geometric reasoning, but you do some algebraic calculations instead. So in this question, I ask you to find the equation of this parabola in standard form. And you should know this, but I just wrote it out to save a bit of time. Standard form is y equals a times x minus h squared plus k. Okay, so what we know about this here, we need to know a and h and k. And here are h. So h equals -1 and k equals -6. So what we're going to do right now is we'll substitute those in. So we've got y equals, we still don't know a, times x minus, and for our h value we've got -1 squared plus k, and k is -6. And this, you should be pretty comfortable with this already, and then we'll just simplify there. So y equals a times x plus 1 squared minus 6. Okay, so all that, nothing there is new. Now the question is, how do we find a? So the idea here is that if this equation represents all the points on this parabola, then we can substitute any points into this equation, and the equation will still be true. And in particular here, we still have one variable. If we substitute one of the points into the equation, then we're going to be left with an equation that will just have an a in it. We'll have an x, y, we'll replace those with numbers, and then we'll just have an equation with a's. So that's going to give us, we'll be able to solve for the a value. That's the idea there. So you can choose any of these points. As a general rule, people tend to make fewer mistakes if you choose one that just has positive values instead of negative values. Or maybe this one, it has one negative value but also has a 0, which makes calculations nice. But any point will get you the same answer. So after I finish this example, you should pause and redo the calculations with another point, and you should get exactly the same a value. So I'll choose this one up here, just because it's all positive numbers. So I'm going to substitute for the x, y values, and I'm going to use this 1 and 6. Okay? And you should write that down. If you can write sub if you want, but you should write down what you're doing so we know where these new numbers come from. So for my y here, I'm going to replace y with 6. Oh, yes, with 6. So I have 6 equals a times, and my x value, x here is going to be 1. So it'll be 1 plus 1 squared minus 6. So I just replace my x and y with the coordinates from this point. So now we've got 6 equals a, 1 plus 1 is 2 squared minus 6. And then here my 2 squared is 4. So I'll write that as 4a instead of a times 4. 6 equals 4a minus 6. And now I need to solve this equation. So I want to isolate a, so to get rid of this minus 6, I'll add 6 to both sides. Let's do this on the next line because I don't really have enough space there. 6 plus 6. So that's my new thing there. And then I'm left with, over here I've got 12, and over here I've got 4a. And then I'll just divide both sides by 4. And I have a equals, a over here equals 12 divided by 4 is 3. And that was exactly what I was after. We should look at this and make sure this makes sense. First of all, does it make sense that a is positive? Yes, it does, because the graph opens up. Parabola opens up. Second of all, does it make sense that a is big, like it's bigger than 1? And it does make sense that it's bigger than 1. This is a tall, skinny graph. Normally, our parent function will go over 1 and up 1. And this is taller than that. Oh, sorry, over 1 and up 1, but this one goes up 3. So that makes perfect sense there. So then the last thing after you find a is you just have to substitute it back into the equation. Because that's what the question asked, to find the equation. So we have y equals 3 times, and then the stuff we need to fill up here, x, I'll use this x plus 1 squared minus 6. And that's the answer. So you should pause the video here if you're not 100% comfortable. Pause the video, do exactly the same thing with one of these other points. It doesn't matter which one. You should also get a equals 3, and you should get the same example there. I'm going to do another example. It'll be very similar here. This. It's going to be this guy here. Get that just in the right place. Okay. So we want to find the equation of this parabola in transformational form. Okay, and then you should have this memorized, but I wrote it down again to save time. So, what are the values of h and k? For h and k, it's the coordinates of the vertex. The x value is h, so here h is 1, and k is 3. A we're not sure of, but we should estimate. A equals, so it's definitely negative. It's negative because it opens down. And then this one, a normal parabola, this one looks wide. Because if we just had one that was congruent to y equals x squared, it would go over 1, and it would go up or down 1. And this one doesn't go up quite that much. And then it would go over 2, and it would go up 4. And this one doesn't do that, so this is wider. So it's going to be something like half or negative a third, something like that. Okay. It's worth pointing out that if a is, suppose it was negative a half, 1 over a would be 1 over negative a half, which would be 2. Okay, so we're expecting that 1 over a will be something like negative 2 or negative 3. Oh, sorry, it would be negative. I think I forgot to say that. Negative 2 or negative 3. Okay, so we start off just exactly the same way as before. Leave that a for a bit. Y minus k is 3. It's going to equal x minus, and h is 1. And now what we're going to do is we'll substitute one of the points. It doesn't matter which one. I'll use this one. Substitute xy equals 3, 1. And if it helps you, write a little xy over top so I don't get them mixed up. It's easy to get them mixed up because they kind of go in the opposite order. So we have 1 over a times y. Oh, there we go. That's what I'm supposed to substitute. So my y value is 1 times 1 minus 3 equals, brackets, here's my x, so I'll put in the 3 minus 1 squared. It's just a coincidence that the 1, 3 and 3, 1 are the same numbers in the opposite order. Okay, so here I have 1 over a. 1 minus 3 is negative 2, so it's 1 over a times negative 2, and then 3 minus 1 is 2 squared. Okay. And then I've got 1 over a times negative 2 equals 4. And now I'd like to isolate 1 over a, so I'll divide by negative 2. Now 1 over a equals negative 2. the question is just to find the equation, we can actually stop here, because what we want to substitute in the equation is 1 over a. I'll include this as a side note here. If we're curious about the a value, which we should be because we want to check our estimate, we'll just flip both of them. We'll take the reciprocal of both. So remember, we'll flip that. A equals, and then we have to flip this side too. So this is currently negative 2 over 1. We flip them and we get negative a half. And that's perfect. That's exactly what our estimate was. Okay, but this is actually slightly more useful if we want the equation in transformational form, just because we want to substitute 1 over a anyway. So it kind of saves us a step if we use that. So we have 1 over a is negative 2 times, here's the rest of the equation, y minus 3 equals x minus 1 squared. So that is the equation of that parabola in transformational form. And again, you should pause that video and redo the calculation with this point here. The only point you can't use is the vertex, and the reason, if you use the vertex, you'll come out with an equation that looks like 0 equals 0, or 0a equals 0, and it won't be very helpful. And the reason is because we sort of already used the vertex when we put in our action k. So if we use the vertex again, we actually don't have any further information about the stretch. We don't know if it's tall or skinny, and that's why you can't find the stretch factor with that. So substitute, pause the video, substitute this one, and make sure you get the same equation at the end. Alright, thanks.